In this tutorial, I'm going to show you how to use the nonparametric bootstrap, or as we just call in class the bootstrap, in order to construct a 95% confidence interval using the plugin method for the proportion of native English speakers from the American Community Survey. And I've already loaded in the Mosaic package. We're going to use that functionality for our resampling procedures. I've also already loaded in the ggplot2 package. So please load those two packages now if you haven't already. I've also loaded the data set, which is actually a smaller random sample of 1,000 observations from the American Community Survey, because about 3.5 million people are sampled in the American Community Survey. And so we want to deal with something a little bit smaller, just so that we can see what's going on a little bit easier. And so notice, if you open up the American Community Survey, that we just have a couple columns as well, again, to focus our attention. And we're going to be focusing on the language column here, which talks about the native language of the respondent. So to begin, we might want to calculate the sample proportion of native English speakers from this sample, and that's what my code in line 15 does. So I'm using the prop command to calculate a sample proportion. The tilde tells you what column to go look at, and the equal English, remember quotation marks whenever you're referring to a character or a categorical variable. What this says is that we want to count the number of yeses or trues for whether or not that language equals English. Running this, we see that the observed proportion of native English speakers in this random sample from the American Community Survey is 0.806. In order to get one bootstrap resample from the American Community Survey, we're going to use that same exact function, the prop language equals English, and then we're going to change what we do in this data command. And we're still going to give it the data set, ACS, but we're going to use this function resample. And what resample does is that it randomly selects rows of the original data set with replacement. And so it's doing all the resampling for you in a pretty easy way. So what you're going to see is if you run this line, you get a different proportion from what you got before, because you have a different random sample of size 1000 that was sampled with replacement from the original. And so you can run this a couple times actually, and you'll get different proportions each time because you're getting a different randomly sampled data set. In order to construct the bootstrap distribution, we need to do that resampling process outlined above a bunch of times. So let's say 1,000 times. So we can use that do function from the Mosaic package. We're going to do this prop thing 1,000 times. We'll relate them using the star. And we can run this, and we'll see that it creates a bootstrap distribution. So now over in the data portion of the environment tab, if you click on English_boot, what you'll see is that we have a data set of length 1000, so we have 1,000 entries in there, and they're all different sample proportions. What's important to note here is that there'll be a different column heading than in your original data set based on whatever statistic you've calculated. So it's important to go look at the bootstrap distribution so you know the name of the column of interest. So now we probably want to plot our bootstrap distribution. So we plug in our data set, which is called English_boot. We need to give it whatever the column name is in the bootstrap distribution, which for us is true, period. And then I like to change the X label so that I know what type of quantity I'm looking at, and these are all sample proportions. So let's run this code, and we should get a histogram, as we can see over here in the lower right pane in our plots pane. And it looks roughly unimodal and symmetric. Of course, we could increase the sample size. Some of that may fill in a little bit, but it's a proportion, so we often see it being a little bit spikier. We can calculate the standard deviation very quickly of the bootstrap distribution just using the SD function, which stands for standard deviation, because the standard error is the standard deviation of the bootstrap distribution. Now here I'm using one of the standard function calls. So I'm giving it my data set, which is English_boot $true, and that will calculate the standard deviation. You can also use functionality found in the Mosaic package, which would say use the tilde to pull off the true column from the dataset boot, and you can also calculate the standard deviation that way. I find this way to be a little bit easier. And I'm going to store that as SE for standard error. So if I run that line, I'm stored. And now to calculate a 95% confidence interval, we need to take our statistic, which we have saved as p hat. We add and subtract 2 times the standard error. And I'm using R as my calculator here. So I can calculate the lower bound quite quickly, which is about 0.78. I can calculate the upper bound quickly, which is about 0.83. So we are 95% confident that between 78% and 83% of people in the United States are native English speakers. This is how you can calculate or construct Bootstrap confidence intervals using the functionality in the Mosaic package, specifically using the plugin method for 95% confidence intervals.